Hi everyone. This is coming to you from Education for All. We are solving problems under trigonometry using the angle addition formula. And I've stated earlier on, the few problems we are going to solve today will mark the end of this topic, trigonometry. We've been doing trigonometry and modeling. That's what we are still doing. We're going to solve a couple of problems, very interesting ones, and that will close this topic. We'll move on to another topic, probably calculus, differentiation. Okay, we've solved the I and B parts of this problem. Now let's look at the last part, which is the C part. We're asked to calculate the exact value of secant of A minus B, given that sine A is 4/5 and sine B is 1/2, where A and B are both acute angles. So we are looking at C, which says sec A minus B. What was the answer for A? A is 3 plus 4 root 3. A was 3 plus 4 root 3 all over 10. Yeah. Three plus 4 root 3 all over 10. And B is 4 plus 3 root 3. 4 plus 3 root 3 all over 10. So these were the answers for part A and part B. Part A is 3 plus 4 root 3, and this one is 4 plus 3 root 3. Now we are asked to find the secant of A minus B. There are various ways to solve this problem. Secant. But other ways are cumbersome. Use other methods, they might lead you into more problems. Because when you see secant, secant simply means 1 all over cosine of A minus B. These two are equal. So if you see this, you should think of this one, the reciprocal of it. When you have our three basic identities, you have the sine of A, you have the cosine of B, cosine of A, you have the tangent, it's called tan of A. The equivalent of these ones, sine is 1 all over cosec of A. Cos is 1 all over sec of A. The tangent is 1 all over the cotangent, call it cot of A. You should be able to know this relationship. That's the sine of A is equivalent to the reciprocal of the cosecant of A. The cosine of A is equivalent to the reciprocal of the secant of A, and the tangent of A is equivalent to the reciprocal of the cotangent of I. So having these ones in mind, we now see that the secant, this one here, of A is reciprocal of the cos of A. So this is what we have here. If that is the case, this problem becomes simple. That's what I was trying to say. You could use this one here. Where is it? Cosine. Yeah. You do this, you expand it, but it's more of problem than taking it from here, which is more or less very direct. So let's see where this one takes us to. What is 1 all over cos A? We have already solved cos A minus B. We know it's 4 plus 3 root 3 all over 10. So what we now have here, this is equals to 1 divided by, then we'll put this 4 plus 3 root 3 all over 10. This is what you have. And I believe you know how to manipulate this fraction. You know what to do when you see something like this. This will become automatically 10 all over 4 plus 3 root 3. You know that this fraction becomes like this. But when we are dealing with answers, given mathematical answers, we normally do not want to see a surd in the denominator. It's not a good way of giving an answer to a problem wherein you have a surd appearing on your denominator. So when we see surds in the denominator, we automatically try to get rid of them. We like to see numbers here, real numbers, it doesn't matter. Integers, okay. But seeing a surd there is not encouraged for you to do that. In that case, well, we have to get rid of this surd. And how do we get rid of this surd? We get rid of this surd by conjugating this denominator we have here. So we conjugate this by saying that 10 multiplied by 4 minus 3 root 3 all over 4 plus 3 root 3 multiplied by 4 minus 3 root 3. When you want to conjugate a fraction, you look at the sign between the integer and the surd. Yeah? This is an integer, this is a surd. The sign between them is the one you change. If it was minus here, then you will put plus. But since this is plus, we are going to have minus in the conjugation. So when you change the sign, only the sign you change, and then you take this whole number, you multiply it top and bottom with the new sign. You multiply it. That is what we have done here. So 4 plus 3 root 3. We now change this sign for it to become 4 minus 3 root 3, which is 4 minus 3 root 3, and multiplied 4 minus 3 root 3 top and bottom. In other words, these two will cancel. 4 minus 3 root 3, 4 minus 3, they will cancel. And you still have your problem 10 over 4 plus 3 root 3. This is just a mathematical manipulation to simplify problems. That's all they are doing there. Now, when you expand, I'll bring it there. Yeah, we're now seeing from here. When you expand this problem, you will now have 10 times 4, which is 40, minus 10 times 3, which is 30 root 3, all over 4 times 4, which is 16. 4 times 4, 16. 4 times minus 3 root 3. So we are multiplying 4 times 3, which is 12 root 3, which is minus 12 root 3. That side is, we now come 3 root 3 times 4. Again, this will give us plus 12 root 3. We'll have here plus 12 root 3. And then you have root 3 times minus root 3. So first of all, 3 times 3, you will have minus 9. This will give us minus 9, yeah? 3 times 3 minus 9. So root 3 times root 3, this will give us 3. The square root of the square of a number is the number itself. So we have multiplying two sorts having the same magnitude inside them. So it's just one number that is going to remain. So root 3 times root 3, you are going to have just 3. So that's 3 now. Let me put it here. Times 3. So 9 times 3, this gives you 27. So you now have minus 27 here. So you can see that this minus 12 root 3 plus 12 root 3, this will cancel each other. It's just like saying 1 minus 1. And that is what we wanted. The surd, we don't want it to be at the bottom of this fraction. So the surd at the bottom is gone. So what you now have here, you now have 40 minus 30 root 3 all over 16 minus 27. This is the bigger number here. It carries the sign. So you'll have minus 11. But is that all? That is not all. What can we do with the minus sign? You now have this minus sign will affect this top number. This minus sign is telling us this is minus 40 plus 30 root 3 all over 11. I've now cleared the minus sign. Yeah, this minus sign we have at the bottom here is gone now, but it changes what we have at the on the numerator. The 40 was positive, it now becomes negative. The 30 root 3 was negative, now becomes positive. That's what the minus sign has done at the bottom here. So what you now have here, if you want, we can still take our 10 out. We see 40, 30 here, so we can say 10. Now this will become 3 root 3 minus 4 all over 11. So this is our final answer. We just factorize. We take 10 out. So this would be 40. 10 times 4 is still your minus 40. 10 times 3 is still your 30 root 3 all over 11. So that's your final answer. Thank you for watching. Bye-bye.